Determine the convergence of the series -1 to the n minus 1 times 4 to the n over n plus 4 factorial. So there's two things going on in here. We have a factorial and an alternating series. But the fact that we have a factorial will take precedence over the fact that this given series is alternating. So we're going to apply the ratio test. The ratio test dictates that when the limit of as n approaches to infinity of n plus 1 over a sub n is greater than 1, it diverges. If it is less than 1, it converges. And if it equals 1, the convergence is inconclusive. So now we apply it to the given series. And we get limit as n tends to infinity of 4 to the n plus 1 over n plus 1 plus 4 factorial all over 4 to the n divided by n plus 4 factorial. So we just simplify this and we get limit as n approaches infinity of 4 to the n plus 1 over n plus 5 factorial times n plus 4 factorial over 4 to the n. Now over here, 4 to the n plus 1 will simply be 4 to the n times 4 times n to the 4, n plus 4 factorial. That will be our numerator. Our denominator will be 4 to the n times n plus 5, which we can remove from n plus 4 factorial. Now we cancel everything out and we get 4 over n plus 5 with the limit as n tends to infinity. When we compute for the limit, we get 0, so that means the series is convergent. And since we use the absolute value for the series and it converges, then we determine that the series converges absolutely.